given that you're climbing a staircase. It takes n steps to reach the top. Every time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Imagine that you are climbing a staircase. So the problem is you're climbing a staircase, and at each step you have 2 choices. You can either take 1 step or 2 steps at a time. The challenge is to find how many different ways you can reach to the top of the staircase if it has n steps. Let's see, for example, in the given example, for n equal to 2, there are 2 possible combinations, 1 plus 1, or you can directly go to the second step. And for n equal to 3, you have 3 combinations. You can take 1 step at a time, or first take 1 step and then climb to the third step by completing the 2 steps together, or first take 2 steps and then 1 step. So if you have only 1 step, you have only 1 possible way to reach to the top of that first step. If you have 2 steps, as you have seen, you have 2 combinations. So as you keep increasing the number of steps, you notice a pattern. The ways to get to the top of the nth step is actually the number of ways to reach to the last step just before that nth step and the n minus 2 steps. So we can easily solve this problem using that logic, and to increase the efficiency of operational efficiency in terms of time, we can also use a cache to store the values or the different number of ways that you can reach a particular step, nth step, by storing it, and every time we need to calculate it again, we can just retrieve the value from the cache. Let's see how it is done. So to code, we actually need a cache first, which will store our known values for 0, also 1, for 1, 1. Since it is given in the problem that for 2 we have 2 steps, let's take 2 also. If you want, we can give for 3 also, because it's already given and known. These are small base cases which we can use. Now we will define a function called climbing, where n is passed, and if n in cache, return cache of n. We just want the value of. If it is not there, then we will recursively call climbing of n minus 1 plus climbing of n minus 2, and then return cache. Return climbing of n. Let's run and see. Oh, this is actually Now let's talk about the time and space complexity. The time complexity will be O of n due to memoization, because each unique subproblem is solved only once and it is stored in the cache. So because of it, the solution is directly fetched from the cache in constant time with O of 1. So the time complexity will be O of n, and for space complexity also it is O of n because we are using the cache.